Hi, welcome to the Calculus 3 lecture series. And we are on the topic vectors and the geometry of space. And we are in the lecture number 3 for this unit. In this lecture, we're going to talk about a new vector operation, which what we call this the dot product here. Okay, so we have a lot of problems to do in this lecture series. I think the total we have 11 of them. So let's get moving. So I'm going to go to our worksheets here. Okay, and so the first thing is here. Okay, so we're going to define what is the dot product here. Okay, so the dot product, based on the definitions here, right? So the dot product, so if you have a vector, so in the R2 or R3, is fine, doesn't matter. So the dot product, basically, you use the first element in the A vector times the first element in the B vector. So that's why it's A1 times B1. Then you use the second element, is A2 times B2. Then you add them. That's what we define the dot product here. Okay, so if in R3, the dot product is the same, right? So you have A1 times B1, A2 times B2, and A3 times B3 is here. Okay, so now let's take a look. So the dot product. So what is your dot product result? So is a vector or is a constant? So the dot product, because you use the first elements times the first elements, add second element times the element. So what you have here, you come out with a constant. Okay, right? So that's why we said, or some people say you come out with a scalar, right? So that means it's a constant. It's not vectors here. Okay, so now let's take a look at the property of the dot product. So the properties, the first, you tell you the dot product, you can switch the order. That does not make any differences. So it will be equal. And also the dot product itself is the length. If you still remember, that's kind of a refresh on memory from the previous lecture. So if my A is like, okay, so in here, so, okay, so I said if A is equal to like A, B, C, right? So remember how do we define the length of the A? We say by using the Pythagorean theory, it will be A squared plus B squared plus C squared, right? So then if you say that if you square out, so this will be A squared plus B squared plus C squared. Then the same things here, if you just use the dot product property, so will be the ABC dot product ABC. So what happened here? The first one times the first ones, right? So it's A squared plus B squared plus C squared, right? That's why the A dot A is equal to the length squares here. And then this property is just similar like a distributive property. If you add two vector first, then your dot product will be similar, will be the same as you dot product each, then add it, right? Okay, then the next one is here. If you have a zero vector, when you dot product in vector A, it will be a zero constant here. Then the last thing here is like, it's kind of like a same makes sense. Also, if you have a scalar constant C times A dot B, so like in here, we know this one is come out with a constant, right? So it will be the similar, you can times the CA and dot B, or you can write this is A dot what CB here, right? So of course, B and A are the vector and A is the constant here. All right, so those properties are pretty straightforward properties, correct? Okay, now let's take a look at some practice ones here. All right, so this one's here, and change the color. So the first few is just a very mechanical. Okay, so let's take a look at the A dot B. So what's that mean? That means it times, so it's 12 minus 3. So this is what? It's 9, right? That's pretty straightforward. Then in here, we use the standard base. That means A, if you write it into the vector form, what is that here? It's 4, negative 3, and 1. So what is the B? You write it into a vector form here. They don't have I, so what that means? 0, right? 5, and 10. Correct? Okay, now you do the A dot B will just be the first one times the first one. So it's 0, negative 3 times 5 is negative 15 plus 10. So what is the answer here? It's negative 5. See here. Okay, so now this one is also very mechanical. A dot B will be 24. 1 plus 0 is 0. 4, so it's minus 24. So this one will give you zeros here. Okay, so now, okay, so the second one is good. They said why A dot B dot C is not defined, but A dot B times C is defined. Okay, so let's take a look at why this one is defined. Because we know that A dot B, this result, what is this result? This result a scalar, right? That means a constant. So let's say it's a constant K. So then this one would be K times C. That's fine. So any vector, you can use a constant to times it. So this is okay. So that's why we say it's defined here. So now let's take a look at A dot B dot C here. So as we just discussed, the A dot B, it will give you what? It's a scalar, right? So we'll give you a constant K. So constant K dot C. Is this one is work? No, because why? Because why do the dot products has to be what? Two vectors. So because of here, because this is a constant, so I cannot do the dot product, correct? Because the dot product has to be what? Two vectors, right? Okay, number 3 is here. They say if A dot A is 1, yes, that's A is a unit vector. So this is true. Why? Because we know that A dot A, we just did, is the length of the A square is 1. So then that's why the length of the A is 1. So we say, what do we say here? We say this is what is unit vectors, right? So from this way. So now we go backwards. So if A is a unit vector, what's that mean? That means the A is equal to 1. Now, what's that mean? That means A the square equal to 1. That means A dot A equal to 1. So the above this one's proof is go if this way, then this one is go this way. So that's why the if and only if state here. Okay, so number 4. Number 4 is also is pretty straightforward one. So let's say A dot B plus C. So I can B plus C first. So we'll give you, so B plus C, so this is 4, 2, and what? B plus C, so it's 4, 2, and what? And 3, right? 4, 2, and 3, it's good. Okay, then A dot B plus C, so that means 1, 3, 1, dot 4, 2, 3. So what is this one here? Is 4 plus 6 plus 3. So we give you what is 13 here. Okay, so these 4 problems are pretty straightforward problems, right? So it's very mechanical. So you make sure you know how to do the dot product. Okay, let's take a look at the next ones here. The next ones here is the angle between two vectors here, okay? So this is a super important formula here. So if the, okay, so if this A and B, so A dot B is equal to cosine theta. So that means how do you find the angle? So the angle for this ones here will be cosine what? Cosine theta is equal to the A dot B over A, the length of the A and the length of the B here. And so also because we know A dot B, so if cosine theta equal to 0, right? So if A dot B equal to 0, you plug in this one, so we know the cosine theta equal to 0. Then what happens here? So they are perpendicular, right? So it's orthogonal, or we say it's perpendicular if A dot B is equal to 0 here. And now I'm going to go to the whiteboard because I do want to show you how to prove the equation. We're not going to do much proof over this class, but only a few, very important type of the proof here. So this is one of them here, all right? So let me show you here. So we want to prove this ones here. So let's say here, this is my coordinates, right? Okay, so then this one's here. Oops. Okay, so here. Okay, and now, okay, now let's assume I have so this will be my A. Let's see here, this is A, okay, and this is B. Okay, okay, so this is my A, this is my vector A. Okay, this is my vector B here. All right. So in here, then here, this is my angle, what? Angle theta. Okay, so those are the two vectors in the, in the space, right? So the first thing here, from the previous section, from the lecture number 2, so we know what is this factors here? So this factor, this is what we call it A what? A minus B vectors, right? So this vector is A minus B vector. And we did this proof, we show it by the graph from the lecture number 2 here. All right, so now let's take a look. How do I show that important, like the formulas here? So the way we're going to do it, we're going to do by the law of cosines here. If, I don't know, you guys still remember law of cosines, right? So if this is the A, B, C, and this one's here face side A, this one faces side B, this one faces side C here, right? So if you have an angle, so if you want to find the angle B here, I don't know you guys remember or not, so the law of cosine is what? It's the two adjacent sides. So this will be the B square is equal to the A square plus C square minus 2BC and cosine B, right? That's what you learned in the, I think you learned this in the algebra 2 or geometry here. Okay, so we're going to use the same law of cosines here, right? So I want to see this, okay, so this one's here, let me try to, so this one I call this is O, and this end is A, and this end is B, right? So kind of match the triangles here. So I know, okay, the AB, okay, So the AB, this line segments, this line segment, AB segment square is equal to OA square plus OB square minus 2OA times OB and cosine theta, right? Let's just find the law of cosines here. So what is this AB segment? AB segment is A vector A minus vector B squares, right? Now what is the OA? A is A vector square plus B vector squares, right? And minus 2AB, and this is what? Cosine theta, all right? Now, from the previous, we know the A minus B square. What that means here? That means, you know, we just talked about it. This will be A minus B, right? Okay, so this will be A minus B, what? Dot A minus B, correct? So it's dot A minus B here, right? That's what we said. A, the length is A dot A, right? So to do same things here. So now we can use the FOIL just like we did before. So the first one here is A dot A. So this is A dot A minus A dot B minus B dot A minus plus B dot B here. So I know A dot A is what? Is A the length square. Now I know the A dot B equal to the B dot A from a previous. So this will be the minus 2A dot B, then plus B dot B again is B to the squares, right? Okay, so now, right? So now this one's here. So that's why we say it's A squared minus the 2AB is here, right? And also we know, so the A dot B is here. Okay, so now let's take a look. How do we simplify this ones here? Okay, so you take a look, we say by the law of cosines, right? So by the law of cosines here, so this is the law of cosines here. So we know the whole distance here, go here, you take a look at, you know, so then the A dot B going to be equal to distance, right, by the law of cosine. So this will be equal to the A square plus B square minus 2AB cosine theta, right? And then you can see here, A square cancel, B square cancel, and the negative you can cancel, become positive. 2 and 2 you can cancel. That's what we got here, right? So we have A dot B is equal to what? Is the length of the A, length of the B, the cosine theta, or you can say the cosine theta is equal to what? Is A dot B, then this is the A and this is the B. All right, so like we said, this is a first super important formula. And for this formula, you can find the angle between two vectors, right? And if the angle is 90 degrees angle, then the dot product is going to be equal to zeros here, all right? Okay, so now let's go back to our worksheets. Let's continue here, right? So that's where we got in here, correct? So here, make sure, you know, it's very important ideas, right? So then if they are dot product equal to 0, then that means these two going to be what? Will be perpendicular here, right? Okay, now let's take a look. They say find the angle between these two vectors. Okay, so let's take a look at the first one. I need to find the length of the A. So what is the length of the A? Is the 1 square plus 1 square, so it's 1 plus 1 plus 1. So what is here? This will be the square roots of what? Square roots of the 3. And the B will be, okay, let's see here, it's 1 plus 25 plus 1. So what is here? Square roots of the what? 27, right? Okay, and now let's take a look at A dot B. So A dot B is 1 times negative is 1, negative 5, negative 1. So what is here? This is negative what? Negative 7 here. Okay, so the cosine theta is equal to the negative 7, and this is the square root of the 3 times the square root of the 27. So then this is negative 7. Square root of 3 times square root of 27 is square root of 81. So this will be negative 7 to the 9. Then what you can do, then you can do the theta will just be arcsine, never cosine negative 7 over 9. So what is here? So approximately is 101 degrees here. All right. Okay, so let's say it's approximately 141 degrees. Okay, so now let's take a look at the other ones here. Okay, the other one, the problem number 6 here, they said, hey, is this vector is orthogonal to this vector or not? So we know the orthogonal, that means the dot product has to be equal to 0, right? So let's take a look at what happens here. This is 6, negative 3, and this is 2, correct? And let's dot product, this vector is 2, 10, and 9, okay? Okay, so now let's see here, 6 times 2 is 12, negative 3 times 10 is negative 30, 9 times 2 is what? 18. So it's equal to 0. So yes. All right. So that is, so we say yes. This is, they are the orthogonal to each other. That means these two vectors, they are perpendicular, have 90 degrees. All right. So this is the this is the angle between two vectors, right? So now let's take a look. This is another one, very important ones here. And we're going to talk about the scalar projections and the vector projections here. Okay, the scalar projections here, because you see, is a scalar projections, right? So what is the scalar projection of the B to A? So the way, you can see like these ones here. So the B to A, the scalar projections here, imagines, right? You have a sun right in here. Okay, sun shining on this B, right? So what is the scalar projection? The scalar projection basically is the length of this shadow, okay? So that's basically is the length of this shadow. Because it's a length, that's why we call is the scalar. And then the notation we say is the components of the B over A, right? That means your sun's in here is the shadow of the B over A here. All right. Okay, so then how do I get this formula B cosine theta? Okay, take a look. If this is the angle theta, right? So the cosine theta, right? So we said what is the cosine theta? It's adjacent, right? Adjacent over hypotenuse. So this is the adjacent side over hypotenuse. So what is the hypotenuse here? is the length. This is the hypotenuse because like if you have a shadow, so this is 90 degrees, right? So that means, so there is the length of the B. That's the hypotenuse. That's why I have the length of the B here, correct? Then what is the adjacent side? Adjacent side is this length, right? It's the length of this shadow. So this is what we call this compo A, the B's here. That's why we find the compo A to B is equal to the B cosine theta here. That's our first formulas here. So the, so it's just by the trig functions, right? Okay, so now is equivalent to, let's say this one is equivalent to A dot B times A. Oh, why? Okay, because in here, let's see, we can show that. So this one is equal to, right? So this is B. What is the cosine theta? Do you remember cosine theta is A dot B over A and the B's, right? So I replace here the cosine theta. I would say this is A dot B, and then this is the A, this is the B's, right? So that is why you cancel. So that's what you get A dot B over A's here. That's what is this formula show you here, okay? And now the next things we're going, so this is what? The COMP, so it's a constant, right? So this is a scalar. So it's a constant, right? So it's just the length of that shadow. So now the next thing here, we say, hey, let's take a look at what is the vector projection of the B to the A's, okay? So basically, we are looking for, is this vector, right? So this is a vector here. So let's put like the arrows here. I'm looking for is a vectors here, all right? So that's why I use the notations here. Be careful, do not get confused. So this is a projection B over A. I'm looking for what is that vectors here. So we know the vector, the way we define the vectors, right? So I can times a unit vector. Then that's what change. So, like we talk about like if the constants times like A here. Okay, so if A is a unit vector, right? Then you create a new vector is C times of this unit vector. So right now we are looking for this is as vector. So that's why I need to use the length, the yellow part. So the yellow part is here, right? So it's B cosine theta. So what I am timing here, I multiply here is A over A. Do you remember in the previous, the lecture we said A over A. What type of vectors here? This is a unit vector, correct? Okay, so now you replace it. So then we know the B cosine theta, right? So B cosine theta is equal to A dot B to the A's here, right? So now you replace it, and then your simple algebra will get you to see. That's why it will be the A dot B and over the A square and times the whole thing times that vector. Right, so if you just do a simple algebra, you will get it, right? Because B cosine theta, we just say the B cosine theta is A dot B over A. Now you times A, and this is the whole thing is times this vector A here, right? That's what you derive to this, so this formula here. So to me, I don't want you to remember this formula because it's kind of hard to remember, but just remember what is the meaning of it, and then you will be able to derive it. Okay, so if you try to remember it, I think that's a pretty hard to just remember all this, right? Okay, so now let's take a look here. So let's say I want to find the scalar projection of x equal to 3i plus j plus k onto y equal to 2i plus 3j. Okay, so now let's take a look here. So the first things here, so I need to find the length of what? Length of x, right? So it's basically it's b. The length of the b is here. The length of the x is here. Remember, is what? Is 3 is 9 plus 1 plus 1. So it's square roots of the 11th here, right? Okay. Then I also need to find the length of the y's here, right? So I find the length of the y. So this is 4 plus 9 plus 16, correct? Okay, so it's square root of the 29 here. Okay, so we said then we need to do, the dot, right? So if you said x dot y, so x dot y, so what is x dot y is here? 3 times 2 is 6 plus 3 minus 4. So what is here? You have 5, right? Okay. So you're going to find here, right? So now we said is the x onto the y's here, right? X onto the y. So based on this formulas here, so the projection, so let's see here, components for the x project to y. So will be the dot product, so it's 5. Then project to y, so this will be, right? So it will be the length of what? Length of the y's here, right? So length of y is what? It's 29 here. So that is, we call it scalar projections here. Okay, and so for the lecture number 3, the video number 1, we're going to stop here. And because this is kind of a long lecture, so I don't want the video get too long for that. Okay, so that's it. So we will stop here, and then we are going to start our next videos here. All right.